Hi, I'm Phil, Youth Services Librarian at Octavia Follin Children and Youth Library. Welcome to Eureka, a STEM program for elementary and mid-school age students. And in this month of November, we are using some programs from an organization called If Then, which is seeking to promote the work of women in STEM who are doing cutting-edge work in science, technology, engineering, mathematics. And this week we're going to be learning about someone named Mercedes Taylor, who's a chemist that works at Sandia National Labs right here in New Mexico. Let's start, before we get into our own chemistry, by learning a little bit more about Mercedes Taylor.
Hi, I'm Mercedes Taylor. I'm a materials chemist at Sandia National Labs, which is part of the Department of Energy. Because of the fact that what I try to do at work is create new molecules, I connect atoms to each other by creating new bonds in chemical reactions, and then ultimately I link those molecules together to make new materials. It's a very physical, tactile, concrete thing to do. And what's most satisfying, particularly on a day-to-day basis, is seeing a reaction work and seeing it yield a solid product. Sometimes you have to isolate your product in really difficult ways, but other times your reaction just leads to a liquid transforming into a solid and precipitating out or crashing out of solution. So if I have some yellow liquid stirring in a beaker or flask, and then over the course of the reaction, a white solid starts to appear and fall out of solution, it's just incredibly gratifying, and that's my favorite part of my job. Well, the work that I'm trying to do is to develop materials to remove contaminants from water. As a society, we're getting very good at removing salt from water in desalination plants, but there are some ions and molecules that are still very difficult to remove, even though they're very dilute. There's not very much of them. So the work that I'm doing would allow us to select for those contaminants and remove them from water, which would save us a lot of energy in our desalination processes and ultimately would allow us to have new sources of drinking water. That's going to be a huge issue in the coming decades because the population is growing and the climate is changing. So it's very important for us to develop new sources of fresh water. Well, I think I had a misconception about STEM. I struggled to enjoy some of my early science classes, and I think that there is maybe a bit of a social stereotype about science or math being just dry and nerdy and unrelated to like human life. But actually the careers that exist in those fields are so fun. They're so fun. And if you study a different field, like maybe you enjoy politics or literature or something, which I think are awesome topics, you might end up with a job where you think about interesting things, but you typically sit at a computer all day and you write about them or you talk on the phone. Whereas if you get a job in STEM fields, it's pretty likely that you'll be moving around in a lab or doing field work, collecting data, and doing really interesting tasks. So I wish that more kids, and especially girls, were aware of that, those long-term benefits of studying STEM. If we show girls what real-life lab research is really like, then they will love it.
Let's take a look at the materials we'll be using in our experiment today. We're going to be doing some chemistry of our own, but instead of cleaning water like Mercedes Taylor does, we're going to be trying to use some chemistry to clean some pennies. So if you pick up a supply kit from the library, or if you just have these materials at home, the first thing that you will need are 6 pennies. And it's better if the pennies are somewhat old and have a little bit of tarnish and brown on them. We're also going to need some materials to clean the pennies with, and you're welcome to experiment and try different ones even than I have here. But I'm going to use a few materials that are mechanical means of cleaning. And by mechanical, I mean that you're actually removing the material from the penny by trying to scrub it off. And so I have some different mechanical means of cleaning. I have a paper towel, a rag, and a scrubber. So I'm going to try some of those just with water to see if I can clean a penny with those. Then, over here, we'll use some supplies that are chemical means of cleaning, which means that these materials actually interact and cause a chemical reaction with the brown stuff on the pennies to cause the brown stuff to come off of the pennies. So actually chemistry is happening when we use these materials. Some of the materials that I have here are baking soda, salt, and white vinegar. I also have some dish soap right here. And I'm going to try that as well. You're welcome. Some of these materials will be included in your kit, but some of them are a little hard to include in a kit, so you're welcome to use any materials that you have at home as well. Now that you've gathered your materials, the next thing to do is take your Pennies Shine chemistry paper and start to make a plan for an experiment that you can use to determine what's the best way to clean a penny. The first thing is to figure out your cleaning materials. As you can see, I have mechanical cleaning, which, as I talked about, is ways that you can scrub something. And so you're not using any chemicals at all, you're just using the surface to scrub the penny clean. So I have a scrubber here, and you can see I've listed that. I also have a rag and a paper towel. If you happen to have steel wool or something like that at home, you could use that as well. And I've listed 3 mechanical means of cleaning. And then I've looked at my other chemical materials, and I've decided that I'm going to try mixing baking soda and vinegar together as one of my chemical ways of cleaning, salt and vinegar, and dish soap and water. And I'm going to see which of those cleans the penny the best as well. Now, I don't want to give too much away because I want you to try your experiments and make your own observations, but I just wanted to walk through what one step in the experiment might look like. So I'm going to do this one first, my scrubber. And so I'm going to get my scrubber, I'm going to take one of my 6 pennies, and the first thing we're going to do is go to this next square, and it says on a scale of 1 to 5, 1 being super, super clean and shiny, and 5 being super dirty, how dirty is this penny before cleaning? And so this is a little bit up to your judgment, but this penny is pretty dirty. It's not very bright. It has a lot of dark brown on it. And so I think I'm going to give this one a 4. It's not the dirtiest it could possibly be, but it's pretty dirty. So now I'm actually going to use my cleaning method, and I'm going to clean my penny a little bit, and then I'll see after a set amount of time. Now I would suggest trying to use about the same amount of time for each of these cleaning methods so that it's a fair experiment. I'm just going to move that out of the way for a second. I'm going to use water for all of my mechanical cleaning methods, and I'm just going to try and clean my penny a little bit here with my scrubber. And even as I'm doing that, I'm seeing some of the stuff come off. I can see Abraham Lincoln a lot better. So I'm going to clean for about a minute. If you wanted to be really, really scientific, you could set a timer. Dunk it in the water again. And here's my penny now after I have finished cleaning. So now the next thing, I'm going to bring my paper back over, and the next question says on a scale of 1 to 5, the same scale, now how dirty or how clean is the penny after cleaning? Well, I was able to get some of that brown stuff off, but not all of it. It's definitely cleaner now, but I wouldn't say it's a 1. So I think I'm going to say that I got it down to, I can't decide between a 2 and a 3. I think I'll say I got it down to a 3. I got it a little bit cleaner, but not as clean as it could be. And so the last thing to do here is how effective was this cleaning method? And so what you can do is you can subtract the left box, how dirty it was before cleaning. You can actually subtract the second box from the first box. So in this case, I cleaned it by a factor of 1. So I did 4 minus 3 and I got 1. Now here, the higher the score, the better. So if I somehow got this down to a 1, that would have been a score of 3. So the higher the number over here means this method of cleaning is going to be a more effective method of cleaning. So now what I'd like you to do is try some of your own. Try your own mechanical cleaning methods, try your own chemical cleaning methods. Maybe you can come up with some combinations or some chemical reactions that I haven't even listed here. You are welcome to even continue down the paper if you want to try even more of your own. Chemists are curious, and so I encourage you to play around and see if you can get pennies to be down to a 1 and see how clean you can get your penny. Thank you so much for joining us for Eureka today. I hope you had fun playing around with chemistry, trying to clean some pennies. Now, if you did this experiment at home and you tried some chemical combinations to clean your penny and you found one that worked really, really well, I'd love it if you could share it in the comment section below and share what you discovered. I hope you were also inspired by the work of Mercedes Taylor, a woman here in New Mexico who's doing important work with chemistry. She can do it and so can you. As always, you're very welcome to join us for Eureka every Monday at 4 p.m. at the Children's Library. I hope to see you next week. Thanks.